Have you ever wondered what's really happening under the hood when you run your JavaScript code? It's not magic, right? It's actually this incredible world of mind-bending speed, super clever optimizations, and a process that works, well, kind of like a five-star kitchen. Let's pull back the curtain and see how it all works. I mean, seriously, just think about it for a second. You type console.log hello, and boom, hello appears. You write a function, and it just runs. But what's going on in that tiny gap between you hitting enter and the computer doing its thing? That's where the real story is. So, to get our heads around this, we're going to use a little analogy. Imagine that Node.js isn't just a runtime, it's a huge, bustling, world-famous restaurant. And deep inside that restaurant, there's one very, very special chef running the whole kitchen. Let's meet him. His name is Veto 8. V8 for short. And Veto, well, he's not your average chef. He is the only one in this whole establishment who's allowed to cook JavaScript dishes. And his one single mission in life? To do it faster than anyone has ever done it before. And that right there, that's Veto's entire reason for being. He takes the recipes that you write, your JavaScript, and he translates them into this super optimized, lightning-fast machine code that the computer's brain, the processor, can understand directly. He's part translator, part speed demon.
So yeah, that's the big idea. From now on, whenever you hear someone say the V8 engine, I just want you to picture Veto, our super intelligent, incredibly fast chef who's in charge of the entire JavaScript kitchen. See? Simple.
Okay, so a customer. That's you, the developer. You write some code and you send the order to the kitchen. But here's the thing. Veto can't just start cooking from your raw recipe. No. First, it has to be translated into a proper structured cooking plan that the kitchen staff can actually follow. And of course, Veto doesn't do this alone. He's got a guy for that. Meet Parser Paul. Paul is the detail-oriented, front-of-house guy who takes your handwritten recipe and makes it kitchen-ready.
So what's Paul's job exactly?
Well, he reads your JavaScript, and first, he breaks it down into individual words and symbols, kind of like ingredients. We call these tokens. Then, he takes those tokens and organizes them into this beautiful, logical structure, a tree of instructions. This is called an abstract syntax tree, or an AST. And that is the perfect structured cooking plan the kitchen needs. Okay, so let's just quickly run that back. Your raw JavaScript code, the recipe, goes to Parser Paul. Paul works his magic and creates a structured AST, the cooking plan. Now that we have a plan, we are ready to actually start cooking. Now this is where Veto's kitchen gets really, really cool. It's not just a one-trick pony. It actually has two completely different speeds for cooking. So it's time to meet the two main cooks who bring this plan to life, Ignition and Turbofan. All right, the first cook to grab that cooking plan is Ignition. Think of Ignition as the energetic line cook. The one whose whole job is to get plates out the door as fast as humanly possible? So, Ignition takes that AST and immediately converts it into something called bytecode. You can think of bytecode as like a set of super simple generic instructions that any computer can understand pretty easily. He executes it right away. And the key benefit here? Your app starts up almost instantly. It's not the fastest it's going to be, but you've got something running right now. But wait, while Ignition is busy getting things started, there's this, let's call him a profiler, who's watching everything. He's noticing which dishes or functions are getting ordered again and again. And when he spots a really popular, hot function, he signals for the master chef. It's time to bring in Turbofan. And this, right here, is the secret sauce of V8's genius. You've got two things happening at once. Ignition acts as an interpreter, just getting your app to hit the ground running with simple bytecode. Meanwhile, Turbofan is the optimizer, the master. It takes those hot functions and painstakingly rewrites them into insanely optimized machine code, a recipe so perfect, the CPU can run it at absolute max speed. So how does Turbofan get so fast? Oh, it's got all the tricks. It'll look at your recipe and remove steps that aren't needed. It'll specialize the recipe, assuming you'll always use, say, numbers as ingredients. It'll even combine small, repetitive recipes into one bigger, more efficient one. That's called inlining. It is absolutely ruthless about efficiency. But here's the catch. All that incredible speed comes from Turbofan making some pretty big assumptions. So, what happens when one of those assumptions turns out to be wrong? Just imagine, right? Turbofan has created this absolutely perfect streamlined recipe for adding two numbers together. It's the fastest in the world. But then, all of a sudden, the code tries to add a number and a string of text. The whole optimized recipe is now completely useless for these new ingredients.
You can practically hear the panic in the kitchen. The superfast code that Turbofan worked so hard on is suddenly invalid because its most basic assumption, that we'd be adding two numbers, just got shattered. And this is where a super smart process called Deoptimization kicks in. It's a safety net. V8 just calmly says, okay, that didn't work, throws away the now useless optimized code, and gracefully falls back to using the slower but much more flexible bytecode from Ignition. It's how your code avoids crashing even when you do something unexpected.
Okay, you can imagine with all this cooking, optimizing, and sometimes de-optimizing, the kitchen can get pretty messy. You've got leftover ingredients, old recipes, just junk lying around. In programming, we call this unused memory. So how does V8 keep the place tidy?
Well, it has a whole dedicated cleaning crew, of course. For all the new, short-lived scraps, what we call the young generation of memory, there's a cleaner called the Scavenger. It's fast, it's frequent, it does quick little cleanups. But for the older stuff that's been hanging around for a while, the old generation, a more thorough team, Mark Sweep and Mark Compact, comes in for a deep clean to free up a ton of space. Whew. Okay, we've met the chef, the cooks, the cleaner. We've seen all the different stages. Now, let's zoom out and put it all together. Let's look at the entire cooking pipeline, from start to glorious finish. And here it is, the whole shebang. Your JavaScript code goes to the parser, which makes that AST cooking plan. Ignition jumps on it, creating bytecode for a super fast startup. The profiler watches for popular dishes, telling Turbofan to create that beautiful, optimized machine code. And finally, the CPU executes that code at blazing speeds. That, my friends, is the V8 engine. So next time you sit down to write a function, you'll know. You'll know about Veto and Ignition and Turbofan working tirelessly behind the scenes. And it really makes you think, doesn't it? Knowing how the kitchen really works, knowing about the high cost of changing your order at the last minute, does it change how you might write your recipes in the first place? Definitely something to chew on. Thanks for joining me.